Today I want to talk about the research I do as a computational extragalactic astrophysicist. I study how supermassive black holes impact the galaxies they live in, and I do that using simulations. You see, when we look out at things in the night sky, there's a lot we can learn, but oftentimes it's difficult to understand how and why things are happening, because we can't go up there and mess with them. We can't touch or interact with the things we study. And a lot of the conditions are way too extreme and complicated to replicate in a lab. So simulations are kind of like an astrophysicist's laboratory. We can mess with variables and change things and see what that does to the universe. The simulations I use model galaxy formation and evolution, including things like gravity, the hydrodynamics of gas, the impact of mergers and the environment, the expansion of the universe, star formation. There's one thing in particular that goes into these simulations that I'm really interested in, and that is called active galactic nuclei, or AGN, feedback. When a supermassive black hole is eating up a bunch of material, this material can release energy, and because it's not actually in the black hole yet, that energy can escape and go out and affect the rest of the galaxy and beyond. When there is a lot of energy coming from this region, we call it an active galactic nuclei. And AGN are thought to play a huge role in how galaxies evolve, because they heat up gas and sometimes completely remove it from the galaxies, which can stop star formation entirely. But the details of this process are not very well understood. It's clear AGN feedback is important. If you don't put it in your simulations, you can't match what the real universe looks like. But there are a lot of simulations out there, and almost every single one does something different for their AGN feedback. Whether that be releasing the energy in different forms, on different timescales, on different physical scales, and they wind up doing very different things to the gas in your simulations, and they can't all be right. So what I do is I take simulations that have different models for their AGN feedback and make mock observations. I model what a telescope would actually see if it looked at the galaxies in the simulations. Then I compare those mock observations to real observations of the universe from real telescopes. Then I figure out which simulations align best and what about their models works well and what they might still be getting wrong. And simulations are always going to be at least a little bit wrong, because the universe is complicated and it is impossible to model everything on all the scales that we care about in astrophysics. But they are also incredibly useful because they do help us figure out why the universe looks the way it does.